Hey YouTube, welcome back. Today we have problem number 17, latent combination of a phone number. It's a medium problem and it's have been asked a lot from Facebook, Amazon, Apple, Google, and etc. So it's a pretty important problem to tackle. So the problem say given a string contain digits from 2 to 9, inclusive, return all possible letters combinations that the number could represent and return the answer in any order. A mapping of digits to letters just look like the telephone buttons in given below. We have this telephone button. Note that one doesn't map to any letters. We have only from 9 from 2 to 9. So for example, we have 2 and 3, we have 2 and 3, and we have 3 letters and 3 letters, 3 multiplied by 3, so we should have 9 solutions, 9 possible solutions, and we have them here. So a way that we can solve this problem is that we could use backtracking. Like we could just create a map, store for in it each number and every number its corresponding letters. And after that, we could create like a backtrack function that will be a recursive function that will try to call itself over and over to add all the 9, all the possible values. So this is what I'm thinking about. So let's just try to do it. So first, I will have I will create const. I'll create a array called combination. Combination, which will equal an empty array, and I'll create a map. Let me copy this one because there's no need to write all the map. I will create a map that represents the numbers and the corresponding strings for it, and we call it letters. Okay. I will do some checks here. I will do first. The first thing that I will do is that if digits dot length equals 0, so we return combination directly, which is return combination. I will create a new variable also. I will call it phone digits, and for now it will be equals the digits only. Okay. And I will create a backtrack function, and I'll call this function with 0 and empty string. Okay, and I should return the combination, and let's just go down. So let's just work on the backtrack function. Basically, this function will got two things: the index and the path. Okay, so right now we call it with 0 and the path is just empty. So I'll say if the path equals, if path.length, equals phone digits.length, because phone digit.length, we should combination dot push. We push the actual path, which the path will represent by the letters, and we return. So basically, what we're doing here is that whenever you create a recursive function, because this function will try to call itself over and over and over, when you try to create a recursive function, the first thing that you want to do is that to think about the base case. the base case that when this case happen, we stop calling this function. So our functions will not run in endless loop. So what I've done here is that I say that if the path.length equals the phone digit length, that means if the path is the same length as the digits, we have a complete combination. We don't have to run the function again. So because of that, I said that. So after that, I will do like, I'll const, I will get like, I will create a variable called possible letters. Which will equals letters dot map. Sorry. Letters dot map. I'll give me. No, not dot map. Dot get. Sorry. Dot get. Give me the phone digits. Dot chart. At char at character at the actual index. So basically we get each number, and after that I will do like a for loop. I will like for const or const let's call it L for letter of each possible letter. Okay. And I will say const new path will equals path plus letter plus L, and I will say okay, the backtrack, I will call the backtrack function again here on index plus 1, and I'll give it the new path. And that's it. But let me run first. Let's see it's work or not. Let me submit it again to see if it work or not. It worked. Okay. So let's talk about it. So basically here, the letter combination function takes a string of digits. Digits as input, like we have string of digits as input, and returns an array of letter combinations corresponding to the input digit. So this is what we return. So first we initialize an empty array called combinations to store the resulting combination. Okay. After that, we create a map called letters. Is created to associate each digit with its corresponding letters on a phone keypad. Okay. Here, if the input string digits is empty, the function immediately returns an empty string. Again, after that, the phone digits variable is set to the input digits to use in the backtracking function. And after that, the backtracking function is defined inside the main function. It takes two arguments. Index represents the current digit index, and path represent the current combination being built. So if the length of the path is equal to the length of the phone digits, a complete combination has been formed, and it's added to the combination array. So it retrieves the possible letters associated with the current digits from the letters map. We retrieve it here, and sometimes I lose my hand. So after that, we iterate through each possible letter and adds it to the path, and then recursively we call the backtrack with updated index path and path. The function effectively explores all possible combination of letters that can be found using the input digits, and resulting combinations are sorted in the combinations array. Finally, the combination result has been returned as a value. So basically, if you can see again here, maybe I guess this is a trick. This is where the tricky part is. So first of all, we have this one to use in the backtrack. Okay, we have this one to use in backtrack. Let's just put it here. Okay, we have this one to use in, sorry, because it's I called it here, so it has to be here. So we have this one to call in the backtrack. Basically here, I'm saying first, this is the base case. This is the base case. This is the actual logic. The base case for me is that when the path.length equals the phone digit.length, because if the path.length and the phone digit.length, does that mean that we have a new string, a new value to push to the combination. So we push it. Otherwise, we continue to call the backtrack on every single string on every single character in the string, and until we get to our base case when the path.length equals phone digits.length. So yeah, that's it for this video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you'll never miss a video, and see you guys in future problems.